Okay, hello everyone to my talk, The Bumpy Road to Universal JavaScript. I'm Johannes, that's my GitHub handle, Johannes, and with one N more on Twitter, because the two N were already taken. I founded a company with my friends in Augsburg. We are called Pirigon. Michael is also part of it. And I'm obviously also on the Webpack team. So before we start, let's do some journey preparations. So what's universal JavaScript? Usually people talk about a web application in the context of web application. And it means that the code is written in a way that it can be executed both on the server and on the client. So how does it work? The server renders the initial HTML. Then the browser starts to render the initial HTML and the styles. And simultaneously, it also downloads a single-page app in the background. And once the client-side code is ready, the website becomes a single-page application. And this part where the client-side takes over is usually called hydration or rehydration. So why do we want to do that? Reason number one, I guess, is performance. Because with server-side rendering, the first meaningful paint happens sooner, and we are leveraging one of HTML's strengths. It's called progressive rendering, because the browser is incredibly good at rendering partial content, and if you're building a single-page app, you basically throw away these built-in performance optimizations. The reason number two is search engine optimization, usually, because back in the days, crawling single-page apps used to be an issue. Now, Google and other search engines are executing JavaScript, but they have they keep it running for kind of 10 seconds, and then they make a snapshot of the page. So you cannot really be quite sure if the crawler gets everything. Which brings us to the last point. I guess it's error resilience, because if we always can fall back to server-side rendering, so even if scripts aren't loaded, are blocked, or failed in some other way, the website still stays usable. So how do you build a universal web application? And this is where we get to the demo. We have the road to universal JavaScript is quite long and it's bumpy, as I already said, so there are a lot of troubles ahead. And let's see how much we can make it in time. But the code is online on my GitHub repository, so if you're interested in, you can take a look there and explore the code. Maybe you want to take a picture of it. Oh, we post on Meetup, yeah, that's good. So, the idea is that we start with a single-page app and we slowly transform into a universal app. So I came up with an idea. The idea is I want to have a website that displays a random fox image. So if I hit the refresh button, there's a loading screen, and then we get the fox image. A lot of cute foxes there. And the setup is quite, it's a regular single-page app. So let's make it a little bit bigger. So we have a app.js. I'm using React, but it's a React Meetup, so I guess it's also fair, but all these learnings apply to different frameworks as well. So I have this async component will mount hook where I fetch the image. And then I set the state to the fox source. And here that's my rendering. Here's a ternary statement where I have if the fox image isn't loaded yet, we display some loading image, and then if it's loaded, we display the image itself. And of course, we're using Webpack, so I import the background image so that we get a nice background image for our site. Okay, so if you want to make that universal, you read the React documentation, and you see that you need to use different rendering methods depending on the environment. So we start with splitting that up. So we have a start client JS. Maybe we should start with let's start with the server. So on the server, we import the component, and then we use the render to string method to render it to a string. And the first thing that comes into and when you see it is that we need to use a function here, because every request that comes in gets a new rendering of the application. So that's quite different to the start module we used to have. So that's in stage 1. That's our start module. We do a regular render, but it's not a function here because we only have to do it once when the application bootstraps. But when we transform to a universal application, the server side needs to do it on every request. So that's a function here. And on the client side, we use React DOM hydrate, which tells React to use the existing HTML and bootstrap the application on top of it. So in the stage 1, we had just a regular index HTML file, and I included the script here, and I used a div with an ID here to bootstrap the application. But when we do server-side rendering, we need to define a place where the rendering will be. So we need to transform that index HTML to a template. So we can use template strings. We could use any templating language, but I'm using template strings because we have it now in JavaScript. And then here is the part where the rendered string is included into the HTML. So let's take a look at the server. So the server is a regular Express application. This is our API point where we are requesting the Fox image from a different API. It's that one, random Fox CA, a very good API. And here we are serving the static content, and for every other request that comes in, we send the index HTML, so that every request gets a new rendered HTML. So one problem that we are facing right now is that inside the app folder, usually I'm very used to write ECMAScript modules, so I use ECMAScript modules everywhere. And so the problem is that we're importing that part here in Node.js, and Node.js has no support yet without a flag, and I don't want to use the MJS extension now. So what would the solution be for that kind of problem? Of course, yeah, let's use Babel. So I think One approach of that would be that you use Babel Node, for instance, to run your Node.js application so that we transpile the server code. So let's take a look at. So that's the start script of our server. Here we're using Babel Node. But that comes with its own problems because now our Babel config becomes more complicated. So if you take a look here, now we need to apply different configurations based on the environment. So for instance, to make ECMAScript modules available in Node, we need to use Babel preset.env. And then we also have this in the application. Here we have this import of the image, and that's also something that Node doesn't understand. So that's why currently the build would fail. So we need to add a special plugin that removes these kind of imports or replaces it. So that's kind of complicated, but I guess it works. So let's try it. Okay, now we're starting Babel Node. Let's request it. And it's kind of strange here because I'm using server-side rendering and it should already have the image, but it's displaying get ready for the Fox again. So let's take a look at the returned source code. And we see that the server is actually returning the loading state and not the final state. So the problem we are hitting right now is that the component will mount. The component will mount function here is asynchronous. But rendering on the server side is synchronous, so when the rendering happens, this hook gets executed, but we don't wait for it. We don't wait for that to finish, so we render the loading state. So one thing we could send. We could just, so for instance, if it's component will mount, we also would see a funny error message when we go in the, when we visit it. So here we also see a beautiful stack trace, really hard to read. Where is it? It also says only absolute URLs are supported. So the problem is that now we are executing the code here on the server, and it tries to fetch from this URL, but we don't have a domain here. So on the server side, this call doesn't really make sense. So you could try to fix it with component did mount, because that won't be executed on the server side. But yeah, then we don't really have server-side rendering. We just send the loading state. So the other approach would be to make that a static method and call that get initial props, for instance. That's what Next.js is doing. And then we could first call that method and then render. Let's take a look. So this approach, sorry. So yeah, so let's fix one problem at a time. So the first problem is kind of this complicated Babel logic, and I also don't want to use Babel node in production because it's in the documentation it says you shouldn't do that. So let's don't do that. So one approach is to create different bundles depending on the environment we're in. So we could split up the Webpack config so that we have a base config here, with the Babel loader and the file loader. And then we use the multi-compiler mode in Webpack. If you return an array of configurations, you get multiple compilations. So first we have web as target. And then we have target node. And we also need to specify different entries here. And one thing is that we are using a different library target in Node so that we can import it as regular module. The idea behind this is that we are trying to uniform the module environment and the platform environment so that on our code that is executed in the same kind of environment, so that we get support for importing images and ECMAScript modules, for instance. And one kind of optimization is you can specify the externals option for the node build, which speeds up the node build considerably because we don't need to bundle all the stuff in node modules. And there's a handy module, it's called Webpack Node Externals. And it's basically the configuration of ignoring all the stuff in node modules because we don't need to bundle that for the server-side part. Okay. So let's take a look at the client server. No. We execute that. We now see that we're doing actually two compilations here. And it creates a client.js and a server.js. And here it has a lot of externals. So I think the interesting part here is at the server index HTML. So now we need to. So this module is not loaded with Babel node anymore. So we need to translate it to CommonJS back. And here we need to import the server bundle. And since we're using a default export, we use the default property here. And of course, we needed to change the script include here. Okay, but so we solved the first problem now. We have one module system and one environment we're running the code in. But now we want to do actual server-side rendering. So one approach, I already mentioned it, would be that we define a static method on the app component and call it, for instance, getInitialProps. And then we also need to refactor the application component that it uses the fog source from the props and not from the state anymore, because we pass it to the application. And no, it's not that thing. So on the server side, we need to wait for the initial props so that we get actual server-side rendering. So that's the part where we call the function, we await it, and then we render it. So one thing we are encountering here is that if we just waited for the getInitialProps call to finish, we would basically just wait before we send anything, and we could already send the head, because the head contains a lot of the document head contains a lot of references that the client could already request. For instance, the client.js. So we need to find a way to make this template string streamable. And there's this awesome module. It's called stream template. And it allows you to use template strings, and if you pass in promises, it will stream the part that comes before the promises, wait for the promise to resolve, and then stream the other part. So our index HTML looks like this. Maybe you're not familiar with that syntax. That's a tagged template string. So we pass the template string and the promises to stream template, and it returns a node stream. So actually, we didn't change a lot of things here. We just used the module. But now this part that comes before the dollar expression here is streamed to the client instantly. So maybe we can take a look at the dev tools. So that's the old application. Let's take a look. No, it's not running. So we see that here we are. The client.js is only downloaded after the document resolved. So if we use actual server-side rendering with the stream template, Rune build. That's a nice typo. The network graph looks very different. So the document is taking a lot longer now to send, because we are waiting for the remote API to respond. But the client.js is discovered a lot sooner. And I think that's really important because in a bigger application, the client.js the entry chunk is usually really big, and it's really hard to get it smaller. So we should try to make it discoverable for the client as soon as possible. It's not working here. Strange, maybe I changed something. Yeah, that used to be this URL. So we already saw that error message here when I run that. I get this funny stack trace here. And that's because our code here, the get initial props code, is executed on the server. So what we do is that we use the actual full URL with the domain. So if you take a closer look here, you realize that the get initial props is actually doing a fetch against our own server. So that's one strange thing when you do server-side rendering, that your client that is, or your application that is rendered on the server does actual HTTP request against your own API, which could be a good thing if the API is hosted on a different server. But if it's the same process, it's kind of strange. And you could maybe you could circumvent it with, for instance, if you're using GraphQL, there's this it's called schema link, where you tell GraphQL that it doesn't have to do actual HTTP requests, but yeah, don't do it and use the same process. But I think it's fine for now. But one thing, if you take a look into the browser console, first we have to switch to development. Now React is telling us that the HTML that is returned from the server is not the same that it's trying to render on the client. So we have to fix that the client needs to get the same rendering props as on the server. Unfortunately, I'm running out of time there. So if you're interested in how to progress, you can take a look at the repository. So I've written down the story so that you can follow it, and I'll link to the different stages, and there you can follow how to transform the application to a universal application. And So there are some lessons learned. Unfortunately, we didn't make it to all lessons. So first try to streamline the module system and the platform environment, and usually it's a good way by bundling creating two different bundles, a client and a server bundle. Create two separate application entries, and these application entries are usually aware of the actual platform environment. Stream the initial HTML, make content discoverable for the client as soon as it becomes available. And stream template, I guess, is a good module. One thing we didn't discover yet is it's a good idea to separate the data fetching from the rendering, because the timing is different on the server and on the client there. The preloaded state you can render it into a script tag in the initial HTML. One thing, and I guess it's if you're already doing universal JavaScript, you need to make sure that this stringified state is not stringified with JSON stringify. It should be stringified with, for instance, serious JavaScript, because if it contains HTML letters, you get a cross-site scripting vulnerability. Long-term caching is also hard. There, it basically boils down to creating a manifest JSON where you get the mappings from your file to the hashes. And code splitting can also become really challenging. But try it out for yourself. I think there are a lot of lessons to learn. Thank you.
So I'm afraid we don't have a lot of time for questions, but maybe one or two. Benedict.
Okay, so one thing that I didn't get really, what do you mean put it into script tags? What do you see as an advantage there versus sending them out as JavaScript files?
You mean that I didn't show that, but the application state is stringified in the script tag itself, and if the state contains user-generated content and the user decides, for instance, to have a name close script tag and insert malicious script tag, then you get a cross-site scripting attack there.
No, what I meant is, what is the advantage of putting it inline into the HTML versus sending it or having it as a separate JavaScript file? Is it just because it's more convenient? Right, but you also disable caching on the browser. If this, whatever you put inside of the script is a lot harder to cache for the browser than what you have in a separate file.
Yeah. So the application itself, it's cached. That's the application code. But the user generated content, it's together with the HTML. I think it's not so good cacheable in a lot of applications. Personally, I would try to cache it on the data level. So
because that contains state that you have on the server side.
Yeah.
Okay. Yeah, then it makes sense. Okay.
One last question.
So I actually tried to do this 2 years ago, and I got stuck in Redux deep down, trying to split reducers and stuff like that. And then about 6 weeks ago, I gave it another shot, and the surrounding tools have developed a lot. So I just wanted to mention that if you want to see this in action, I'm currently writing an interactive tutorial that shows you how to do all this. And it's more advanced. It has authentication, user system, data fetching with Apollo. It has its own API. It connects to a GraphQL server that is hosted from Prisma, and it's pretty advanced by now. And the URL is wh.now.sh, if you want to show it maybe.
What's the URL?
So would be interesting to see how far you've got and maybe compare the approaches.
So of course we will share the link on the
On-
Meetup
yeah, I think that's the
page,
best,
so you
yeah.
can post there in the comments. Maybe that's a more convenient way.
Just a small Webpack question. If you have a multi-stage build, so that you build for Node and you build for the web application, is it possible, or is there any caching for stages that are similar between both stages to speed up the process of building the app?
As far as I know, it's on a file level. It caches the file is only read once. I guess Tobias is.
Yeah, if you have, you can cache the result of the transformations on module level with a cache loader, and with the cache loader you can share the cache because it's on the file system with a cache loader between multiple builds. Should work. But it's on module level. On application, on compilation level, it's difficult to cache because you inject some node environment, the server or client, and there are differences between the after pass result of the module between server and client.
So one other question, you didn't choose Next.js here,
Yeah.
which essentially does all of that. Is it just for learning purpose, or is there a problem that you see in Next.js?
No, I think Next.js is pretty good. They have a slightly different approach, but it was for learning purposes. I think it's when you start to develop these kind of applications, I think it's good to first try it for yourself, because then you see what you get from Next.js. And but they have, and I see multiple frameworks emerging there, and I guess there's kind of progress there, but it's also a hard problem.
I think we run out of time, otherwise we will run too late. Let's have a 5-minute break, because then we will have 2 more talks, and we don't want to be disappointing to the last one. And so be back in 5 minutes, please.